Okay, another derivative that we're probably going to attack with a substitution. Now again, if you lack fear and common sense, you could expand this. We have x squared plus 6 to the 8th power. You could multiply that out, use the binomial theorem maybe to make it go a little faster, and get a great big polynomial, and then integrate that. But that sounds like too much work, so let's see if a substitution can make this easier for us. We have here this 2x, so the derivative of x squared plus 6 would make 2x. If we take this piece inside here and say u equals x squared plus 6, then the derivative of that would be 2x dx. And that's very interesting because we have exactly 2x dx here, so this looks like a good substitution. By the way, if you just take, I'm just going to do this wrong for a second to show you something. You might consider just saying u is x squared, because then the derivative is 2x dx. But if you do, that part works out okay, but then when you do your integral, you'd end up writing integral, the x squared turns into u, and you still have this 6 hanging around to the 8th power du. This is okay, but if you include the 6, it doesn't really make any difference to the derivative, so why not include it? You kind of get rid of the 6 for free. If you do it and include the 6 in your substitution, then your integral ends up being just u to the 8th dx. So this is even simpler. So anytime you have a constant, you probably want to include it in your u because the derivative is just going to clear it out anyway. This is a better deal. You get a simpler integral if you do this. If you don't include the plus 6, you may get away with it, or you may get an integral that's still unsolvable. So if you have a chance to include a constant in your substitution, you probably want to do that. Okay, we'll get rid of the green. That's not the ideal substitution. So u to the 8th dx, the antiderivative for that would be u to the, increase the power by 1, divide by the new power. Don't forget your plus c. So there's the antiderivative done, and now that it's done, we can revert back to our original variable x. So wherever the u was, we put x squared plus 6 instead. 1/9 u to the 9th power plus c.